petrological study can be complete without a proper understanding of textural development of the rock. Texture depends upon the rate of crystallization and composition of magma. Because texture gives an idea about the rate of cooling, depth of cooling, and also depend upon the crystallinity and granularity of the rock. Therefore, textural study is very important for the proper understanding of rock crystallization.
These textures give the idea about the depth, rate of cooling, and magma composition, so that we can understand on the basis of textures and composition about the origin of a rock.
Primary texture. Zoning. Zoning refers to compositional zoning in minerals and relates to changing composition from core to rim. The compositional zoning in minerals implies that complete equilibrium was not reached during crystallization, recrystallization of the rock in question. At any given time, it is only the rim of known minerals that is at equilibrium with the matrix. The preservation of a zone profile in a mineral demonstrates that the interior of the crystal has not equilibrium under the changed condition, a potential insight into the early history of the rock. Compositional zoning are the most commonly and conspicuously observed in plagioclase, olivine, and pyroxene, and the rock-forming minerals. Plagioclase constitutes an isomorphous series between two end members, anorthite having composition Cal2 Si2O8 and albite having composition NaAl Si3O8. Microscope studies of plagioclase crystal from igneous rocks show zonation which can be normal, core more calcic and rich than rim, oscillatory occurrence of large number of thin layers, alternately rich in calcium and sodium. Granophyric texture. Granophyric texture is a synonym, although it originally referred to less regular type of intergrowth. Rocks completely made up of this texture are called granophyres. Graphic texture. This results from the intergrowth of quartz with alkali feldspar. Each mineral is in optical continuity over large areas, although they are apparently separated into a number of individual crystals. Myrmekite. This is an intergrowth of quartz and plagioclase, the quartz occurring as a bulbs or tubes within sodic plagioclase. It commonly occurs at plagioclase potash feldspar boundaries and appears to result from replacement of the plagioclase by potash feldspar. Perthite. This is really a feature occurring within a crystal and therefore is not strictly covered by our definition. Perthite is plagioclase forming bulbs, rods, tubes, lamella etc. within potash feldspar. Antiperthite is the similar developed of potash feldspar in plagioclase. Post-solidification and reaction textures. Certain textures are the result of reaction between early formed crystals and the enclosing melt. Similarly, changes may occur after the rock has solidified either to glass or a mineral aggregate. Depending on the scale and nature of these changes, they may be classified either as texture or structures. Reaction rim. This is a zone of reaction products surrounding a mineral grain or an aggregate. If the reaction is the result of primary magmatic process, the texture is referred to as corona. If it results from late hydrothermal solution or later metamorphism, it is known as chalophytic border. Olivine, pyroxene, garnet and amphibole are the important minerals involved in such textures. Spherolytic texture. This texture or microstructure is found chiefly in acid volcanic rocks and result from simultaneous crystallization of fibrous minerals in a radial arrangement about a common center. The spheres may be complete or segmented due to interference with neighbors. They range from less than a millimeter to several meters in diameter. Most spherulites are composed of quartz and feldspar, grow rapidly in viscous supersaturated solution. Orbicular texture. In some plutonic rocks, nuclei may be surrounded by concentric shells, each composed of radiating fibrous minerals. This can result in ball-like segregation, several centimeters in diameter, thus called as orbicular texture. Rapa-Kibi texture. In certain granitic rocks, phenocryst of potash feldspar are enclosed by polycrystalline aggregate of small soda-rich plagioclase crystals. Two main origins have been considered: magmatic crystallization or metasomatic replacement. Felsitic texture. This is defined as an extremely fine aggregate of quartz and alkali feldspar.
The Rapa-Kibi texture present in granite, so easily we can see that potash feldspar is surrounded by sodic plagioclase feldspar. The genesis as well as nature of a rock. While the same rock we cut and make a slide for thin section studies, then on the basis of texture present, that also give the idea about the genesis and on the basis of different minerals, we can name properly.
Because of the chemistry, extremely high temperatures are required to allow such a magma to be extruded at the Earth's surface. The magma will also be rapidly supercooled to glass. However, the simple neosilicated structure of olivine means that it is difficult to get it to enter the glass phase. It develops long skeletal plates or rods. Adjacent crystals compete and form a network reminiscent of the leaves of the Western Australian spinifex plant. Hence, it is called spinifex texture. This type of crystal growth is rapid and is the result of quenching. Basic, ultra-basic plutonic rocks. The emplacement of large bodies of hot basic magma deep in the crust allows gradual cooling, with crystals forming in the order of Bowman reaction series. These crystals are considered to gradually sink through the magma and build up successive layers on the floor to the magma chamber. Rocks derived from such accumulation are known as cumulates. Primocrystal, a crystal that nucleated and grew within the magma. Cumulus crystal, a primocrystal that has become attached to the floor, walls or roof of a magma chamber. Intercumulus material, the product of solidification of primary liquid originally trapped within cumulus crystals. Hyperbasal and basic volcanic rocks. The abundance of tabular plagioclase crystals may result in a network such that only smaller triangular or polygonal spaces are left between the crystals. These spaces may be filled by small granules of olivine, pyroxene, etc., thus defining an intragranular texture. If the infilling materials are glassy or cryptocrystalline, the texture is said to be interserratal. Directive textures are the result of magma flow, and they may grade or overlap with what should be more strictly defined as structures. However, there are certain features that result from crystal alignment and which do not destroy the uniformity of the rock. An alignment of tabular feldspar laths in the general direction of flow defines a trachytic texture. If the feldspar is interwoven with glass and not other crystal, the texture is hyalopellitic. Trachytic texture is most common when the mineral involved is potash feldspar. Similar textures involving potash feldspar in plutonic cyanides are referred to as trachytoid. Vesicular texture. This term refers to vesicles within the igneous rock. Vesicles are the result of gas expansion which often occurs during volcanic eruptions. Pumice and scoria are common type of vesicular rocks. The image on the screen shows basalt with vesicles, hence the name vesicular basalt. Xenocrust. This is an individual crystal that is foreign to the magma. Xenocrust may become incorporated due to volcanic process or be removed from wall rocks. Because they are very vastly different in composition, they frequently result corona texture. Xenocrust of similar composition to the magma can occur but would be almost impossible to identify. Xenolith. This is a fragment of pre-existing rock, not an individual crystal, that becomes incorporated in an igneous melt. Xenoliths range from less than a millimeter to several hundred meters in size. If the foreign material is genetically related to the host, it is termed a cognate xenolith. If it is unrelated, it is said to be an accidental xenolith, usually just termed xenolith. Many orbicular textures are centered on xenoliths.